tutorial. So I'll ask a question. What is microscopy? What is microscopy? What do you
Can I
understand
try?
this term microscopy?
Can I try?
Yes, go on.
The study of how a microscope works,
Yeah.
something like that.
So we have small objects that we are not able to see using our naked eyes, isn't it? Okay. So the
Uh-huh.
study of those small objects that we cannot see using our naked eyes, using an instrument called a microscope. Okay. So we'll be using an instrument called a microscope. Okay, to study those small objects that we cannot see with our naked eyes. Okay, that is what a microscope is all about. So we'll be studying small objects that we cannot see with our naked eyes using a microscope, isn't it? Okay. So now there are terms and terminologies that you need to know about this microscopy. Okay. So one of them is magnification. Okay. So what do you understand by the term magnification? Anyone to try? What do you understand by the term of magnification?
Uh,
Okay.
it's like enlarging something small to something visual.
Yeah. So we are trying to enlarge something which is small. You make it big so that you are able to see, isn't it? Something to make it visible. Something very small, something very tiny. You are trying to make it visible. Okay. So that's what magnification is all about. Okay. So we'll talk about the formula for magnifications as we are moving. For now, I just wanted you to understand what magnification is all about. Okay. So the other term you need to know is called dissolution. What is dissolution? Okay. So dissolution is given by this formula here. Okay. So dissolution donated by small letter r is equal to lambda. Okay. So this lambda stands for the wavelength of light. Okay. Then divided by 2NA. The NA in this case is called the numeric aperture. Okay. So this is the formula for resolution. Okay. So that's what you're having. So what does resolution mean? What's the meaning of resolution? What's the meaning of resolution? Okay. So resolution is simply the ability of a microscope to distinguish two closely spaced objects as separate entities, isn't it? That's what resolution is. Okay. I've already given you the formula for resolution. Then this resolution is going to be affected by the wavelength of your light. Okay. So the bigger the wavelength of light, the smaller the resolution. And the higher this resolution, the greater you are able to see whatever you want to see under the microscope, isn't it? So that's what resolution is. Okay. So three things to take note of: the wavelength. So if you're having greater wavelength of light, you end up having small resolution. Okay. And also take note of the formula for calculating resolution there. Okay. Are we clear on what resolution is?
Yes, we are.
Okay. So we can move. So now you notice that on the formula for resolution, we had the lambda, which was the wavelength of our image, divided by 2NA. Then we've said NA is what we call numerical aperture. Okay. So what is this numerical aperture? So numerical aperture is simply a measure of lens's ability to gather light and result fine spacing detail at a fixed object distance, isn't it? Okay, so that's what numeric aperture is. Okay, then you also have other terminologies like contrast. What do you understand on your own words? What is contrast? What is contrast? What is contrast?
The difference between two things.
Okay, so, yeah. So when you are trying to differentiate two things, that's contrast, isn't it? Okay, so
Yep.
Yeah, so that's a simple term for a contrast. So how we are going to be differentiating these two things, we are going to be using different types of stains, okay? So we'll be using stains to differentiate two things. One of them we are going to discuss about the gram-negative and gram-positive bacteria. So we'll be using certain stains to differentiate these two bacteria. So using those stains, we are able to tell which one is a gram-negative bacteria and which one is a gram-positive bacteria. Like that, isn't it? Yeah. So that's our contrast. That's what you have in there. Okay. Then you also have what we call field of view. Okay, so this is the distance of the visible area when looking through the microscope. That's what the field of view is. Okay, so these are some of the terminologies I wanted you to take note of. Okay, so can move. So now I'll give you an assignment. When you leave class, you should take your time to try and look at these the parts of the microscope. Okay, try to know how a microscope look like, and also identify some of the parts of this microscope. Okay. Then what we are going to do here, we're going to do run through some of the function of these parts of the microscope. Okay. So one of the parts is the eyepiece. Okay. What's the function of the eyepiece from your secondary? What did you learn? What's the function of your eyepiece? Okay. So what's the function of the eyepiece? So it's the one you use to view your what? Your specimen, isn't it? That's the eyepiece, isn't it? What of the objective lens? What's the function of your objective lenses? Okay. What's the function of the objective lens? Is there anyone in class? Anyone to give it a try? Okay. So what's the function of the objective lens? Okay. So these ones are the ones which have these the evolving nose piece, isn't it? That holds the multiple objects, okay, of varying magnification. So you can have magnification at 4 times. You can have magnification at 10 times. You can have different magnification, isn't it? So that's the function of the objective lens. Okay. You also have the stage where you usually place your specimen, isn't it? Okay. Then usually the source of light is going to be the illuminator. Okay. What was the condenser? What's the function of the condenser? Okay. People, what's the function of the condenser on a microscope? Okay. So this one is the one which focus the light to the specimen, isn't it? That's a function of a condenser. So this one focuses light to the specimen. Okay, to the specimen. From your source of light, which we've mentioned is an illuminator, isn't it? So that's a function of the condenser there. Okay, so those are some of the parts of the microscope and their function. We also have the diaphragm. Okay, what's the function of the diaphragm? So it's the one that controls the amount and the angle of light entering the objective lenses. Okay, so that's a function of your diaphragm, isn't it? Okay. What of the focus knob? What's the function of your focus knob on a microscope? These are some of these are things you already know. We are just trying to remind each other here and there. Okay. So what's the function of the objective knobs? Okay, so it's the one used to adjust distance between your objective lenses and the specimen, isn't it? Okay, so that's a function of your objective knobs there. Okay, now let's talk about this magnification. I said I'll give a formula for magnification. So far, I've given the formula for resolution, which was lambda. So take note of these formulas. You can be asked in your test or your exam. So lambda is given by 2NA, which we've mentioned. The N there is the image wavelength, and then the lambda is the image wavelength. Then the NA there stand for what? Numerical aperture. Okay. So now we also have the formula for magnification. Okay. So now the formula for magnification will depend on the type of magnification you are carrying out. Okay. So you can have the formula for magnification. Let's say for a linear magnification. Linear magnification is given by this formula. Okay. Linear magnification is given by this formula. So you have view of magnification. I'll use capital letter M to indicate magnification. So magnification is going to be given by V divided by U. Okay, small letter U there. So this V stands for the image distance. So this is the image distance. Image distance. Okay. Then the U there stands for the object distance. Okay, so you can get your magnification by getting your image distance, then you divide it by the object distance. Should be able to get your magnification. That is what we call linear magnification. Okay, so that's one of the types of magnification you can have. Okay, so you can also get your magnification from a compound microscope, like the one we've been given here. Okay, so this is for the magnification for a compound microscope. Compound microscope. So their magnification is given by, so you get your magnification of the eyepiece. Okay, so you get the magnification of the eyepiece. You multiply by the magnification of the object. Okay, multiply by the magnification of the object. So get the magnification. Remember, we had those magnification 4 times, 10 times, can be 100 times. Okay, you multiply with the magnification of your object. Okay, so that's in terms of the compound microscope, if you want to get your magnification. Okay. Okay, so you can also get a magnification from what we call photo microgram. Okay, so you can get a magnification from photomicrogram. Okay, so magnification for this one is given by you get the size of the image on a paper. Okay, so you get the size of the image on a paper, then you divide with the actual size of that specimen. Okay, so you get the size of the image on a paper, then you divide with the actual size of the image or the specimen. Okay, so those are the types of magnification you can have and how to calculate them. Okay, so you can use linear magnification, you can use compound magnification, you can also use photomicrograph magnification there. Okay, so know these formulas you can be asked. Okay. Okay, so we've already talked about resolution. Okay, then we have types of microscope. So you have two types actually. Okay, so there's what we call light microscope. Okay, and what we call electron microscope. Okay, okay. So what do you understand by light microscope and electron microscope? What do you know about these things? What do you know about these two types of microscope? Anything you know about the types of microscopes? Okay, let's interact, guys. Feel free to ask or to contribute where you are not clear. Any contribution? Anything you know about the two types of microscope? Can be the light microscope or electric microscope. What do you know about these two types of microscope? Okay, so for a light microscope, it uses light waves, isn't it? Okay. Then for electron microscope, it uses electrons. Okay. So that's what you have. That's what you have. That's the difference between these two microscopes. Okay. Okay, so this one uses light to transmit through the specimen, isn't it? Then the other one uses electrons to transmit through the specimen. Okay, so those are the two types of microscope you have. So let's discuss them one by one. We also see some of the examples of this microscope. Okay, so we start with electron microscope. Okay, it's also known as dissecting microscope. Okay. So what have we said this microscope is all about? What does it do? What does it use? Hello? Hello? Okay, so for electron microscope, we are saying it was using electron. For light, it was using light waves, isn't it? Okay, so a good example of electron microscope is what we call scanning electron microscope. Same. Okay, so what are some of the features of this microscope? The electron microscope, you really need to know the features, and you really need to differentiate what between the light microscope and the electron microscope. Okay, so these are some of the features of the electron microscope. Okay, so in terms of illumination source, we are talking about the source of light here. Okay, so the source of light is usually from a beam of electrons. Okay. Okay, then the lenses there, here you have electromagnetic lenses, isn't it? So what you're having on SEM, okay, or electron microscope, you have what we call electromagnetic lenses. Those are the types of lenses you have in there. Okay, the magnification, it has extremely high magnification. Okay, resolution, very high resolution there. Okay. Okay, then the specimen must be viewed in a vacuum and must be dead and specially prepared. Okay, so use it to view a dead specimen. Okay, and that specimen should be in a vacuum. So that's in terms of the features of this electron microscope. The image which is produced from the microscope is glassy scale. Okay, so it's black and white. It's a black and white image you are going to get from an electron microscope. Okay, so those are some of the features you need to know about the electron microscope. Okay, are we clear up to here? Any question? Is everything okay? Are people following up to here? Okay, so if all is well, we can proceed to the types of electron microscope. So we have different types of electron microscope. Okay, the common ones I'm going to mention here are two. I've already mentioned one, which was the scanning electron microscope. The other one is called transmission electron microscope. Okay, so how it works? So this one uh, transmit electrons through the beam of an ultra thin specimen to produce a what? A 3D high resolution image of the internal structures. That's how this transmission electron microscope is going to work. Okay. Then you have the scanning electron microscope. So this one, the electron beam scans the surface of the specimen, and the secondary electrons are detected to produce a highly detailed 3D. So in the transmission microscope, we are producing a 2D image, isn't it? Then in a scanning microscope, you are able to produce a 3D image. Okay, so take note of these differences. That's where you are going to be asked here. Okay. Okay. So that's what you're having. So I've put a YouTube video which can help you differentiate between a transmission microscope and also um, scanning electron microscope there. I'll share the notes after class, and I'll upload the class on YouTube. Okay. So are we clear on the electron microscope? Is everything okay on electron microscope? Okay. So if all is well, can proceed. Okay. Okay, so we go to light microscope. Since we've said there are two types of microscope, which you've mentioned, light and electron microscope. Light is also known as optical microscope. Okay, so what are some of the features for this microscope? Okay, so the source of light, we get it from visible light. Okay, then the magnification, so it's a bit lower compared to electron microscope. You can see here. So the magnification for electron microscope was very high, but this one is a bit lower, okay, compared to an electron microscope. Okay, it also has limited resolution, and we've said when we started this class, we said resolution is limited by the wavelength of light, isn't it? Okay, so it also has limited resolution here. Okay. So in terms of the specimen, you can view it, whether alive or dead. The other one, for the electron microscope, we said we use it to view dead specimen, isn't it? In a vacuum. But this one, you can use it even on a living organism. Okay. So that's what you have here. So those are some of the features of light microscope. Okay. So types of light microscope you can have the bright field microscope, okay? You can have the dark field microscope, the phase contrast microscope, and a fluorescence microscope. Okay, so I'll share with you the notes so that you go through and see how these microscope work. Okay, so you should be able to tell how these microscope, each of these microscope work. Okay. Okay, so I'll quickly go to the last part of the tutorial, which is about staining. Okay, so now we said when viewing those microorganisms on a microscope, we usually use stain, and staining helps us to differentiate the microorganism, isn't it? Okay, so one of the stains we can have is called gram stain. Okay, so gram stain, this one, it is used to differentiate between two types of bacteria. Okay, so bacteria can either be one, they can be gram negative, they can be gram negative, or they can be gram positive. Okay, so different types of stain will help us differentiate the two types of bacteria. So we use stains. Those stains, they are able to tell us, depending on the color we are getting, they will tell us whether the bacteria is gram negative or the bacteria is gram positive, isn't it? Okay. So we did need to know the procedure for this gram stain. Okay, what do we do for us to perform gram stain? Okay, so this you usually do is as an experiment. You go in the lab. So the procedure you follow is this one. The first one, you prepare a smear. Okay, so what is a smear? Okay. Anyone to help us define what a smear is? Hello, what is a smear? Hello. Okay, so a smear It's something, a sample you usually put on a slide, and then that slide you usually place it on a microscope if we are to relate it on in microscope. Okay, so it's your sample. In short, your sample, that sample that you put on the glass slide of your microscope. Okay, that is called a smear. Okay, so the first step you do is to prepare your sample or your smear, isn't it? Okay. Then the next step you do is to hit fix the smear. Okay, so you hit fix the smear. Okay, so you hit to fix your smear there. So the first procedure we prepare your smear. The next procedure is going to be hitting. Okay, so you hit to fix your smear there. Okay, then after hitting, what's the next step? Okay, so now you stain. So you use different types of stain to stain your smear. Okay, so you can use a good example. Most of the time, the common one you usually use in the lab, which you are going to use, is crystal violet. Okay, so you use your crystal violet there to stain your sample. Okay, okay. So you can also use iodine. Those are different, the other types of staining, but the most common one you usually use is the crystal violet one. Okay, that's what you have there. Okay, so these are the other types of stains you can have. Okay, so you have the one which you use alcohol. You can also have safari there. Those are the types of staining you are going to have. But the common one we usually focus on is this one, the crystal violet stain. Okay. So what do we do on the crystal violet stain? Okay, so you've prepared your sample. Okay, you've prepared your sample, you've hit your sample. Then now you're adding crystal violet stain. So I said that I'll focus on this one because the common one you usually use. Okay, so you put your crystal violet stain on this sample. Okay, so what will happen if you put your crystal violet stain to the sample and you have a bacteria here? What will happen if the bacteria is gram negative? And what will happen if the bacteria is gram positive? What do you think will happen? Okay. What do you think will happen if your bacteria is gram negative or if your bacteria is gram positive? Then you add your crystal violet stain there. What will happen? Okay. Okay, so for these bacteria, for a gram-positive bacteria, it usually retains a crystal violet color after staining. So when you add your stain to this smear, you usually notice that the crystal violet color will be retained towards the end of your experiment. Okay, but for a gram-negative bacteria, it won't retain that crystal violet color. Okay, so you end up having an orange color at the end of the day. Okay, so when you add your smear there to your sample, when you add your stain to your sample there, if you notice that there's a return of a crystal violet color, then you should be able to tell that the bacteria which is there is gram positive bacteria. Okay, so it's a gram positive bacteria. Okay, then if there is no return of your crystal violet color, it's a gram negative bacteria. The color you usually see most of the time is going to be orange, something like that. Okay, so those are that's what staining is all about, the gram stain. Okay, so are we clear on the stain? Are we clear on the stain? Okay, so the reason why we are getting, we return the crystal violet color in the gram-positive bacteria is because of it having a thick peptidoglycan compared to the gram-negative. So gram-negative, it has a thin peptidoglycan. Okay, so because of this peptidoglycan, the thick peptidoglycan in a gram-positive bacteria is able to return your crystal violet color. Now, this gram-negative bacteria, it will have a thin peptidoglycan. So this one is not able to retain your crystal violet color. That's the reason why you end up having results looking like this. Okay, so you view under a microscope, you notice that if the bacteria is gram negative, you get a view like this. Okay, so if your bacteria is gram negative, you get a view looking like that. If your bacteria is gram positive, you get you end up retaining your crystal violet color there. You can see if you view it under a microscope, you get a color looking like this. Okay, so you know that your bacteria is a gram positive bacteria. Okay, so that's what you have there. Okay, okay. So I've put an assignment for you. Okay, so you can try it. These are MCQs based on the topic we've done. So there are about 5 MCQs. You can try them and send me answers on my inbox. Okay, so there are 5. So you can send your answers on this slide. Then I should be able to confirm just to see if you've gotten whatever we've done here. Okay, so do you have questions? Do you have questions? Any questions up to here? Any question on microscopes? Okay. So if there are no questions, we can end here. That was just an intro on biology. So next time we'll meet, we'll start looking at the cells. Okay. So for today, we'll end here. Then I'm going to upload this on the website. And if you want to access our website, you can easily follow these instructions I'm going to give. So you can open your browser like that. Then you type Discrete. Okay. So you open your browser. That. Then you type Discrete. Okay. So you type Discrete Learning Institute. Okay. So it will come like that. You can open our website there. When you open, if you don't have an account, if you want to subscribe to a course, okay, of your choice, you can easily go there where it's written subscription. So you can subscribe for a course of your choice. Then when you subscribe, you should be able to access more classes and other things. Okay. So we are also going to be recording some of the classes on our YouTube channel. So you can just go on YouTube, you search Discrete Learning Institute, you'll find videos there. Okay. And I'll upload the notes for this tutorial on our website as well on WhatsApp. So if you are in our WhatsApp group, I'll send the notes there. Okay. So we'll end here if there are no questions.